Mr. B. Dhanasegar is working as a lecturer in Department of Information Technology, Anna University, Chennai. He finished his MCA from Urumu Dhanalakshmi College, Bharathidasan University. He finished his ME in Computer Science and Engineering from College of Engineering, Anna University. His areas of interest are multi-core programming and architecture, programming models, compiler, automata theory, cryptography, and algorithms. He is an expert in subjects like compiler design, formal languages and automata theory, analysis of algorithms. His research area is code generation for multi-core architecture.
Welcome to the UGC lecture series on computer science. We have the compiler design subject, and we are seeing actually the operator precedence parsing. So, there are two categories of parsers, one is the top down parser and another one is the bottom up parser. And the bottom up parser we have shift reduce parsing, the operator precedence parsing, and another one broad class of parsers called the LR parsers. So, we are actually studying the operator precedence parsing, so which is going to be operating or which is possible only with a specific type of grammars called operator precedence grammars. So, a grammar is said to be operator precedence only if the right hand side has that is right hand side should not have two consecutive variables. You can have even a single terminal, no problem, or you can have continuously any number of terminals, but no question of having two consecutive variables on the right hand side. In that case, we will be not able to call the grammar as that is operator precedence grammar, and if the grammar does not satisfy the operator precedence property, then which may not be given as input for an operator precedence parser, because of the operator precedence parser constructs the precedence relationship among every pair of operators available in the grammar. So, that will be successfully that is done only if a single variable is there in between two consecutive that is variable terminals, or there are two consecutive terminals possible, or it may be a single terminal also. So, now it is required to find out that is the relationships which are going to be defined among the various terminals available in the grammar. So, there are three number of terminals we are having. So, one is going to be the less than relationship, so which denotes the left end of the handle, and then the second one is going to be the greater than, which denotes the right end of the handle, and the third one denotes the equal, which is denoting the interior position of the handle. That means, suppose if I am having a variable followed by a terminal, then it denotes that a handle is yet to going to start, that is the terminal is going to be the handle there which is going to start. So, the variable and a terminal are going to be related by less than relationship, and if we are having a terminal followed by a variable, then this terminal is going to be the end of the handle. So, it is going to be related by greater than symbol, and suppose there are two consecutive terminals or three consecutive terminals, then they all together forms a single that is handle. So, they all should be considered together for reduction. So, in that case, when you are defining the that is relationship, there is a precedence relation among terminals which are continuously available, they all are related by equal symbol, saying that we are yet to find out the rightmost end of the handle, so that we can carry out the reduction operation. So, these three are going to be the relations which are denoting that the left end of the handle, the right end of the handle, and even the interior position of the handle. The handles or the relationships, how we are identifying. So, there are two number of sets we are going to define. One is called the leading set and another one is called the trailing set. So, now as far as the leading set is concerned, its meaning is the first terminal for every non-terminal, that is every non-terminal should be capable of deriving a string of its own, then only the grammar is going to be a valid grammar. So, in that case we should find out what are all the possible terminals. The reason why we compute this leading set is, so the first terminal in a that is sentential form of a variable is to be related with the sentence or the last terminal available in the sentence which is produced by the previous variable. So, there is a need for computing some relationships. So, for that we need all the first terminals, and similarly we need all the last terminals also. The first terminals are computed by a set called leading set, and the last terminals are computed by a set called trailing set. So, how we will be defining the leading set here is the set of all small a such that, so a derives in one or more number of steps. So, gamma a delta, where gamma is either epsilon or a single non terminal. So, we are looking into the very first terminal. So, the very first terminal may be directly available in the very first position, provided the right hand side starts with the terminal, or it may be available just next to the first symbol, provided the first symbol is a variable. But anyway, we are very sure that it cannot be the third symbol, because we cannot have two consecutive variables on the right hand side of any production, as it is going to violate the operator precedence grammar property. So, this gamma is either a single epsilon or it is going to be a single non terminal. So, if you are collecting all this, we can't say that there will be exactly one symbol be the output for this leading set, as there may be chance for having multiple rules for A also. So, in that case we should know, that is find out the set of all terminals which are all available or which are all possible in the very first position of the that is variable on the right hand side in the derivation. Then when you go for the trailing set, it is going to be the last terminal of the derivations. So, here the same story once again, we have the set of all terminals called A, such that the A derives the sentence in one or more number of steps, gamma A delta. Since it is going to be the last terminal we are talking about, we are not bothered about what is gamma, but we are concerned about what is this delta. So, delta is going to be epsilon, or it should be a single non terminal. So, when you move from right to left from the rightmost end, we will be either seeing a terminal first, or we will be seeing a variable, and next to that immediately we will be finding a terminal. So, whether we get a terminal directly or we get a terminal after just keeping a single variable, and that terminal is going to be in the trailing set of that A. So, once again there is no need of looking into the third symbol, since this particular variable is going to be a single variable, and we cannot allow that two consecutive variables on the rightmost end or even on the leftmost end. So, this is how we are computing the two sets. One is going to be the leading set, and another is going to be the trailing set. So, these two sets are mandatory in order to compute the precedence relations which you have listed earlier. So, the three possible precedence relations are, one is going to be precedentially less than, which denotes the left end of the handle, and another one is precedentially greater than, which denotes the rightmost end of the handle, and another one is the precedentially equal, which denotes we are somewhere in the interior position of the handle. So, we need to compute these relations among every pair of terminal, so that we will be able to find out the that is precedence relations. So, next is having known that is the leading set and the trailing set. So, we have to find out how we will be evaluating the precedence relations. Before that, let us see that is what is going to be the algorithm for the leading set computation. So, the question is, what are all the non terminals for which we need to compute the leading set, that is for each non terminal A, and there are some number of terminals already available in the grammar, we are not sure about, and what list of terminals are going to be coming under the leading set of that particular variable. So, we make everything as false first of all. Its the meaning is, in the beginning there is no terminal available on the leading set of the variable called A, that is why we make everything as false. So, now we are looking into the various productions are of the form A derives A alpha. So, what should be done is, A derives A alpha means we are interested in computing the leading set of the variable called A. So, A derives A alpha, and the right hand side is starting with the terminal. So, we know that this particular terminal is going to have the presence in the leading set of the variable called A, or otherwise it can even be of the form A derives B followed by A alpha, where B is once again a single variable and followed by A is there. So, in that case also we find small a is going to be the first terminal on the right hand side. So, whether it is going to be A derives A alpha or A derives B followed by A alpha, we need to make the entry of this capital A comma small a or this capital A comma this small a as true. How we will be doing that is, we will make a call for the install function called AA, install function with that is A comma A, which makes that entry as true first of all, and that is not the end. Here we have to understand that, see for example, suppose if we are taking the second rule, A derives B A alpha, we compute that this small a is going to the first terminal from the left for this A, and at the same time this B is also going to be expanded to any number of that is exponential forms, because B may also have some number of rules. So, when you expand this B with its own rule, there is a chance that the terminal, whatever is the first terminal available in this B, will be the first terminal of A. So, that is what we go for, that is a continuation of a loop operation. We will put that entry, that is A comma A, into the that is symbol the stack, that is data structure, and from the stack data structure we will pop the top. See for example, suppose if we find that the top pair is going to be B comma A, then we will be looking for all productions where B is the first variable available on the right hand side. So, A derives B alpha. So, the meaning is, that is for each production of the form A derives B alpha, where B is going to have going to be the first symbol available on the right hand side. So, if B comma A is a pair from the stack, it means small a is the first symbol of B. If small a is first symbol of B, then it is going to be the first symbol of even A also. So, that is what this iteration is. So, we find what is going to be top entry in the stack. The top entry in the stack says that small a is going to be the first terminal or the leading symbol for capital B. So, now we are looking for all productions where capital B is going to be the first symbol in your right hand side. So, we are having A derives B alpha. So, now we go for installing that is A and followed by that is small a. So, this will once again install this particular entry into the symbol table, that is symbol table in the stack, as well as make the entry for A comma A as true. So, this will ensure that all the leading terminals for a variable will be computed by this loop. So, if you do it only in this step, it will find out only the straightforward leading symbols, but when you get inside this particular loop, it will find out in a recursive manner that is all the symbols which are possible to be the first symbol on the right hand side. So, that is the algorithm for computing the that is leading. And now to look at the trailing operations. So, the similar algorithm, but with a little modification. Once again we make that that is trailing set for all the variable and terminal combination, that is your variable A, and for all terminal combination we make it as false, assuming that initially we do not have anything as the trailing symbol for the variable called A. And next we will be looking for the collecting the information about the possible terminals which will be the trailing terminals for the variable called A. So, it is going to be of the form A derives alpha A or A derives alpha B, alpha A B. So, if it is A derives alpha A, then we find that this small a is going to be the very last symbol. So, the last symbols are supposed to be in the trailing set of this capital A. So, this A comes into the capital A, and the next one is we have A derives alpha A B. So, we find B is going to be the last variable, and if you move from right to left, the first terminal, from the right to left you are moving, the first terminal is going to be small a. So, that is last as far as the right hand side is concerned. So, we will be making an entry for A as true, and from this also A as true, as they are going to be the last terminal or the trailing symbols for the variable called A. Once again, as I stated earlier, they will be finding only the terminals which are directly available as the last terminal will be available from this install operation. But now it is required to find out the terminals which are even indirectly available as the last terminal. See, for that every entry we are making into the install that is symbol which we need to add it into the stack. So, we will be having the stack operation. So, we will be pushing them, and we will go for a loop where we will pop the top pair, which is going to be b comma a, and then we will be looking for productions of the form a derives alpha b. So, what should be done is this time every entry corresponding to this b, that is all trailing symbols of this b will be the trailing symbols for even a also. So, that is what the idea. So, we will go for, that is for each production of the form a derives alpha b, we will install a comma a, saying that small a, if it is going to be there in the trailing set of b, it is going to be trailing set of even a also. So, that is about the algorithms for leading computation and trailing computation. So, having computed the leading set and the trailing set, we will be able to think about the construction of the precedence relation by using some algorithm. So, I will continue this algorithm after a short break. Welcome back. We have just seen the there is algorithms for leading set computation and trailing set computation. Let us see one simple example, and after that we will see that how the precedence relations are computed. So, here is the grammar, the expression grammar, which is unambiguous. So, E derives E plus T or T, T derives T star F or F, and F derives open bracket E closing bracket or ID. So, by the definition of the leading, we need to find out the first terminals from the right hand side. If you take the very first rule, E derives E plus T, we know that this is your variable. First of all, this grammar is an operator precedence grammar, as there is no two consecutive variables, and this variable you can skip. The first terminal is going to be plus. So, we will be going for plus, and the next one is once again this E, we can expand this. So, whatever be the number of times we are expanding, so this is going to be E, or it can even be T also, and if it becomes T, we should go for finding the first of T. The first of T we find T star F. So, star will be in first of T. So, first of T will become first of E now. So, star will be there, and when you look at this T, so continuously we can expand this T by T star F. So, every time it will introduce only star as the first terminal, but when you move from there is T to F, so the F will be introduced as a first variable, and in turn F is expanded. When we expand F, it is not recursive, it is going to be stopped the expansion, because of we find that is opening bracket as the first terminal, or it can be even ID also. So, as far as F is concerned, open bracket and ID are the first terminals. So, all the 4 terminals are coming as the outcome for the leading set of E. So, it includes plus from E plus T, star from T star F, opening bracket from opening bracket E closing bracket, and ID from there is F derives ID. And looking at the trailing set, there is leading set of T. So, instead of starting from E, we will start only from T. So, all terminals collected from E plus T will be missed. So, we will be having only T star F or F. So, we will be having star from T star F, and opening bracket from opening bracket E closing bracket, and ID from F derives ID. And the next one is leading set of that is F. So, it is going to be opening bracket comma ID, it is going to be straightforward, that is operation. F derives opening bracket E closing bracket gives you opening bracket as leading symbol, and F derives ID gives you ID as the leading symbol. So, that is about the leading set, and now we need to compute the trailing set. It is simply the reverse. Instead of looking for the terminals from the left, we will be looking for the terminals from the right. So, we have plus from E, still plus will be there in the trailing set of E, star will be in the trailing set of T. So, this time here, instead of that opening bracket, since we are looking for the terminal from the right to left, we will be having closing bracket from the opening bracket E closing bracket production, and ID anyway it is a unique terminal. So, it will be there in both leading set as well as from the trailing set. So, if you are computing the trailing of E, we will be having plus star opening bracket and ID, and trailing of T, it is star closing bracket and ID, and trailing of F, it is going to be closing bracket and ID. So, that is about the leading and trailing set computation for the expression grammar. So, now having computed this leading set and trailing set, we can compute the precedence relations among the various terminals in the grammar. So, it requires a simple algorithm how we are computing the precedence relations among the various operations. So, we will be having three cases. How do you find out the or establishing the less than relation, and how do you that is define the greater than relation, and how do you define the equal relation. So, let us see the algorithm. So, we have the productions of the form A derives x1, x2, x3 etc. up to xn, that is your the grammar where x1, x2, x3 etc. xn means. So, they can all be terminals, that is one possibility, or that is a variable means it should be enclosed by two variables. So, two terminals both on the left and right there should be terminal. So, no question of having two consecutive variables, because it is not being supported by an operator precedence grammar or operator precedence parsing. So, we take for example, the grammar the production of the form A derives x1, x2, x3 etc. up to xn, and now we need to establish or just find out the relationships, that is the precedence relation, it can be either less than or greater than or equal among every pair of this xi's. So, that is what this algorithm is trying to do. So, we will continue from that is 1 to that is n minus 1, because the last one is going to be a single that is variable for which we cannot compare it with anything else. And now the condition is, if you are having two that is grammar symbols xi and xi plus 1. So, if both are that is terminals, then set the xi is equal to xi plus 1. That is, if you are having two consecutive terminals, then it means that the relationship among xi and xi plus 1 are equal, as it is not denoting the end or the beginning of any handle, it is denoting only the position is somewhere in between terminals, it is not the left end or the right end. The second case is, so if I is less than or equal to 2, it means we will be having three symbols for comparison. One is going to be xi, and the next one is xi plus 1, and the third one is xi plus 2. Here if xi is terminal and xi plus 2 is also a terminal, provided xi plus 1 is a variable, then we will be defining the relationship once again xi is equal to xi plus 2, that is two terminals which are separated by a variable or a non terminal. So, if two terminals are separated by a non terminal, then the relationship among those two terminals is defined as equal. So, we will be having the situation like if I is less than or equal to n minus 2, which will be ensuring that there are three number of symbols for comparison, xi and xi plus 2 are terminals and xi plus 1 is a non terminal, then we are setting xi is equal to xi plus 2. And now we are going to see two number of additional rules which will be telling the usage of leading set and trailing set. So, here if we find that xi is a terminal followed by xi plus 1, that is first we have a terminal followed by a non terminal, then so the condition is this terminal is going to be lesser than all the that is leading terminals available in your xi plus 1. Since we say that it is going to be the beginning of a handle, that is xi is a terminal means your xi is going to be less than the small a is going to be all leading symbols available in xi plus 1. So, we set the relationship as less than. So, xi precedentially less than a, that means when you have xi and this a, this is going to be the beginning of a handle which requires a separate reduction and nothing to do with this your xi. And in reverse, if xi is a non terminal, that is first we have a variable and then followed by that we have a terminal, that is your xi plus 1 is a terminal, then for all a in trailing of xi we have to set a is greater than xi plus 1. So, this is a trailing relationship or trailing set computation, and the relationship is greater than. So, which says that the handle ends with a and the handle has nothing to do with xi plus 1. So, that is denoting the right end of the handle, but whereas the previous one was denoting the left end of the handle. So, now this algorithm is telling that there are 4 number of steps available. The first step says that how do you set the equal relation provided two consecutive terminals are there. And the second step says that once again how do you set the equal relation provided a terminal followed by a variable immediately followed by a terminal. There is two terminals separated exactly by one variable. And the third step is how do you denote the left end of the handle, and the fourth step is how will you denote the right end of the handle. The left end of the handle is denoted by the xi, that is going to be a terminal less than all the leading symbols of the xi plus 1, and the last one is we have the some xi followed by xi plus 1, but here the relationship is the trailing set of xi are all going to be greater than the xi plus 1. So, with this we can just compute the precedence relation. So, here is the example. So, this is a operator precedence grammar, since we are having E derives E plus T or T, T derives T star F or F, and F derives open bracket T E closing bracket or ID. So, everywhere we find a terminal bounded by variables or two terminals enclosed by separated by a variable. So, no question of having two consecutive non terminals. So, this grammar is going to be a operator precedence grammar. And now we look at the various parts. Actually, we want to have two consecutive terminals case, nothing is there here. Then two terminals separated by a variable, we have only one. So, in that case also we find the relationship can be defined. So, opening bracket we find it is precedentially equal to closing bracket. So, this is what the relationship. So, we have opening bracket here and it is precedentially equal to the closing bracket. So, this intersection says that if you are in between there is opening bracket and closing bracket, it does not denote the left end or the right end of the handle, only the middle position of the handle. So, that is the part, and then we have to find out whether there are two consecutive terminals, it is not there, but there are cases where a variable followed by a terminal or a terminal followed by a variable. Once again variable followed by terminal, terminal followed by variable, variable followed by terminal and terminal followed by variable. So, now apply all these rules we have studied so far. So, here this E plus means the trailing of E are greater than plus. So, trailing of E is plus closing bracket and there is star and even dollar. So, in that case, so what should be done is, so you think about the plus, we will be clicking plus on G. So, this is what, so plus is greater than plus, star is greater than plus and closing bracket is greater than plus, and even ID is also going to be greater than that is plus. So, that is what we are getting. This column entries which are where we are having greater than symbol entries are obtained from the E plus, and look at plus T. So, this is going to be your plus, you just look at the there is row for plus, and this plus T, what kind of information we will collect is plus is going to be less than all the leading symbols of T. So, plus is here, leading symbols of T include star, opening bracket, ID. So, it is going to be plus is precedentially less than star, plus is precedentially less than opening bracket and plus is precedentially less than this ID. And when you are looking into there is T star, we know that it is going to be T followed by star, it says that the trailing set of T are all going to be greater than star. So, we will be looking star here, trailing set of T are star, closing bracket and ID. So, we have star greater, closing bracket greater and ID greater. In star F, star is the symbol which is going to be less than all leading symbols of F. So, star is here, leading symbols of F includes only opening bracket and ID. So, opening bracket is less than and ID is also less than, and here we have the all trailing symbols of E are greater than closing bracket and all leading symbols of opening bracket is less than all leading symbols of E. So, that will give you the rest of relations. And one important thing here we find is they have a different additional column called dollar both row wise and the column wise. So, there is a need for looking into that is the beginning of the parsing process as well as the ending of the parsing process. So, when you begin the parsing, we will not be having anything in the stack. So, we must say that there exists a terminal which denotes nothing has been recognized so far. So, whatever be the symbol following, they all should be shifted onto the stack. That means they all should be made as precedentially greater, so that they will get into the stack irrespective of the symbol available on the top of the stack. So, we must have a special symbol which is nothing but the dollar, and that will make everything to be pushed inside the stack by setting the relationship less than, less than, less than and less than. But certainly we cannot start a string with the closing bracket. So, there is no relationship defined in between dollar and closing bracket, but you can start a string with plus, you can even start with a string with the star, you can even start with the opening bracket, you can start with id. So, this is all going to be less than, and similarly we have a dollar on the column. The first one was about beginning and this is about ending. So, how will you end the parsing process? That is, we want to have a dollar, that is, once you see the dollar on the input buffer, that is when you are seeing dollar on the as the end of the entire string which we are supposed to be passed, we have nothing else for shifting. So, whatever is there in the stack all should be that is reduced. Reduced means they should be processed immediately. So, that is the reason why we make plus is greater than dollar, star greater than dollar, and no question of ending a string with opening bracket, but a string can be ended with a closing bracket, since it is going to be an there is an expression. So, closing bracket is going to be greater than dollar and id is going to be greater than dollar, and dollar is undefined, since we find that the dollar and dollar will denote an empty string. An expression cannot be empty, a string can be empty, but an expression cannot be empty. So, there is no point in defining a relationship in between dollar and dollar. So, this is how we are constructing the precedence relation. So, to summarize, we have seen that is how we are constructing the leading set and how we are constructing the trailing set, and three relationships less than, greater than, and then we have seen the algorithm for precedence relation, that is how we are constructing precedence relation with the help of the leading set as well as the trailing set. So, once we have constructed the precedence relation, so this could be used for parsing any string provided the precedence relation variable is uniquely defined. That is, in between every pair of there is terminals, if the relations are uniquely defined, which is going to be true as far as the grammar is unambiguous, and if the grammar is ambiguous, there is a chance for having even duplicate relationships. So, that may not be able to may not allow you to that is parse a string in an unambiguous manner. And the questions, the leading set, trailing set computation, and constructing leading and trailing set for the given grammar, and how we are constructing the that is operator precedence table for the given grammar, and parsing with the help of the precedence parsing. So, that is all about these questions, and with this I complete this episode. Thank you all.